we want to talk about the when we want to use the least square regression or the linear regression, when we want to use, okay, what kind of problem. So here we are telling that the question we want to ask is it good to use this model for my data? We want to ask that question. You have a set of data. Is it good to use this model? Now, there is a way of checking that, okay? So you do a scatter plot of your samples, and then you try to find out, is there a strong linear correlation? You know, it's like a strong linear form. Like this is the linear form, okay? So when the linear form can be positive or negative. Like here, with the increase in the area of a house, the price increases, okay? So linear form can also be negative, like let's say when the horsepower of a car increases, let's say the speed increases, okay? The price also increases. This is all positive linear relationship. But the mile per gallon reduces, okay? With the increase in horsepower, the miles per gallon will reduce. So that's a negative linear relation or negative linear dependence, or negative linear form, but still a linear form, okay? So you can, when you do the scatter plot like this, you can check the linearity. So this is the visual check, but visual check may not always be good because the points may be very scattered or far away from the regression line. The errors are high. So there is one way of numerically checking it also, okay? That is called the checking of the strength. So what is the strength? How closely the instances in a scatter plot follow the form's pattern. Are they very scattered away, far off? No. If they are not, then we check this. So this is called the numerical check. Is called using a correlation coefficient, or R. So correlation coefficient measures the direction and the strength of a linear relationship. Okay, so it kind of it's a unitless item, and the value of a correlation coefficient R varies from -1 to +1. -1 when there is a strong negative correlation or negative linear relation, and +1 when it's a strong positive relation. Okay, so we want to see a strong relationship. Then only we can model it is using a least square regression. Okay, so how the R is calculated, this is the formula for R, and so this is basically you can see that xi minus x bar here. X bar and y bar are the average or the mean values of the samples you have, and let's say you have n number of samples, n is the sample size, x bar and y bar are the sample mean, and sx and sy are the sample standard deviation. So once you have those values calculated, you can calculate the value of R, and you can check whether it's close to +1 or close to -1. Once we calculated the correlation coefficient R, then and we are sure that least square regression or a linear regression is a good model for my data, I can calculate for the least square regression the slope B1 and intercept B0 once I have the value of R. Okay, slope B1 is calculated by R times Sy divided by Sx, where Sy and Sx are the sample standard deviations, and we calculate the intercept B0 from Y bar minus B1 times X bar, where Y bar and X bar are the sample mean. Okay, so also we need to know that the proportion of variation explained by the least square regression is equal to R square. Now we will see some examples of using the correlation coefficient.